This is an example from your book. It's a beam that is connected to a wall with a cable, and it has a force with 500 newtons on it, and it's pinned at point A. Now we're trying to find the reactions at point A and the force in the cable, and this requires to go through all the 5 steps. So I'm going to write down the 5 steps we need to solve this problem. So step 1 is system. Choose your system. Step 2, draw FBD. Step 3, write the equations. Step 4, solve. Step 5, interpret or verify your solution. So that's all what we need to do. So here I choose this beam as my system. So this is what I'm going to use as my system, and if I choose that as system, I can draw a free body diagram, right? So if this is the beam, then in order to draw free body diagram, we need to go through surface forces, body forces. Every single time we draw FVD, we have to find these effects, right? So now, in order to find the surface forces, I start walking around this system, like starting from this point, and then I start walking this way, right? So the first thing I cut is this pin at point A, as you can see this location, right? So in order to find the force at point A, I ask the question, can I move this beam to the right easily? And the answer is no, because the pin connection at point A prevents it from moving to the right. So there's going to be a force from the pin that is welded to the ground. This pin is going to apply a force in the X direction to the beam at point A. So I just represent that with a force like this. Don't worry about the sign if it's to the right or left. I just call it AX, as force at the point A in the X component. Now in order to see if we have a Y component, we ask this question again, can I move this beam in the Y direction easily? And the answer is no, because again the pin is applying a resistant force in the Y direction and we don't know it. So I just put it right here, unknown, AY. And now, in order to find the static moment at point A, I ask this question, can I rotate this beam around point A easily without applying a torque? And the answer is yes. There is no friction, assuming the pin at A is frictionless. So I'm not going to put a moment at A like MA, because there is no moment there. And now I start going back to my system and continue walking on this borderline until I come and cut this point, this force here. You see that? Now I should include this force in my free body diagram because this is external effect. So I go back and put that force right here, and its value is 500 Newton. If I know the value, I just put it here. If I don't know it, I introduce a new variable for it, right? Now we know that this distance is also, let me write, this distance is also 3 meters from point A, okay? Now again I continue walking on my system on this borderline, and the next thing I caught is the effect of this cable. The force of the cable is applying to our system, which is in this case is the beam. So now this force is only in this direction. There's not going to be component like that. It's only along a cable, and it's always tension. A cable cannot apply a compression force. So having said that, we come back to the point and we try to include it in our free body diagram. So there you go. This is the force, and because I don't know it, I put a variable like t. I introduce a new variable, unknown t, and it's going that way. But don't forget that from the figure we know the slope. So this is 4, 3, and this is 5, right? So I go back to my picture and I continue walking around this, and as you can see, I come back to my start point. This was my start point, right? Okay, now I'm done with surface forces. Now I have to go, so I'm done with surface forces. Now I go to body forces. Now I ask this question, how much is the weight of this beam? Now assuming that this is almost massless, or the mass is small, I can ignore the body forces, and then in this case I'm done with free body diagram, or step 2. So I'm going to check mark step 1, step 2. Now I'm ready to write the equation, so I put the question mark because I'm working on this step, right? So how many questions do I have here? The questions that I have in 2D, I only have one system. Let's call it system 1. So per system in 2-dimensional space, I have 3 equations, and they are summation of force in x, which is resultant force in x. You already know how to compute this. Should be 0 according to the law of equilibrium. Summation of force in y, which is resultant force component in y, should be 0, and summation of moment about or around any point should be 0. So these are the equations of equilibrium, right? So I'm trying to write this equation for this given system, assuming that let's choose a direction. So let's say this is my positive x and this is my positive y, right? Because you choose the direction of your coordinate system and its alignment. That's one of your jobs, right? Now assuming that this is my direction, now I go ahead and rewrite this equation. So let's first write the summation of force in the x component. So what I'm going to get, starting with t, so I'm trying to start with here, right? So let's clean this mark here. All right, so starting with t, that's going to be 3/4 times t, which is t times hold on, this thing, I made a mistake here. All right, so t times cosine of that angle positive, and since cosine of that angle is 4/5, t times 4/5 is the cosine of that angle positive. So now the next thing is 500 Newton, but that's in the y direction. It has nothing to contribute to the x direction. Now the next thing is ax, so I say plus ax, and ay is in the y, so that I'm pretty much done here, is equal to 0. That's the first equation, right? Now I go to the second equation. In the y direction, the component of the tension force in the cable is t times 3/5, the sine of the angle positive, and then I have a negative 500 Newton down, and then I have a positive ay is equal to 0. Now it's time to go to the moment equation, this equation, the third equation, right? What point should I choose in order to get the most simplified form of moment equation? Well, the point that I choose is this point that I'm showing it right now. You see this point? I use it with a cross, a black cross. That is a particular point that two variables, ax and ay, two unknowns, are going through that. They're concurrent. So I can easily get rid of them and minimize my number of unknowns. If I choose this point, like this point right here, right, then I'm going to have a moment from force t and a moment from 500 and a moment both from ax and ay. So I'm going to get one equation and all the three unknowns is going to show up in the equation. So the system of equation become coupled and the solution procedure become longer, right? So I am not going to do that because it makes my job a little bit harder, right? So now let's go and choose point A as my center point for moment. So summation of moment around A should be 0, right? So the secret is you try to choose a point that most of force are going through that point. So you eliminate the force coming from the unknowns, right? So now if I write the moment on A, we automatically know that the moment of AX is 0 because it's going through A. Moment of AY is 0 because it's going through A. Next thing is 500, so it's going to be 500 times moment arm. You don't even need to move it, right? It's already normal. Times 3, positive or negative? It's negative. Use your right hand. Now let's go to this force T. Now if you have two components, this one is the X and this one is the Y. Remember, in calculating the moment, the first step was to break it down. The second step, move. The third step was to get the moment arm and compute the moment. So this component, the X component, is T, as I mentioned before, times 4 over 5, and the Y component is T times 3 over 5, right? So these are two components. Now you can easily see that, let's work on the X component. You see that this X component is going, its line of action is passing through point A. So its moment is 0. So we just get the moment come from the Y component, this guy, right? And the moment is equal to moment arm, right? It's already orthogonal, we don't need to move it. So the moment arm is the entire length of the beam, which is 5. Look at the picture here. This length is from this point A is 5, right? 3 plus 2 is 5. So moment arm would be 5 times the value of force, which is T times 3 over 5, right? Positive or negative, use the right hand, and then you get positive. So 5 times T times 3 over 5 is going to be your moment generated from the tension in cable, right? And that's pretty much all of it is equal to 0. So now I am ready to check mark equation step number 3. So I go here and put a check mark because I am done with the step number 3. I have written all the equations, and because I have one system, I only have 3 equations. If I had 2 systems, I would have had 6 equations, right? Now I go ahead and solve it. Now I'm working on this step. Well, what equation should I use? Let's number the equations. So this is equation 1. Let's call this equation 1, equation 2, and equation 3. Now I ask the question, what equation should I start first in order to get one equation, one unknown, and solve it, and then substitute backward in all equations and get all my unknowns, which are the reaction at point A, which are AX and AY, and the tension in the cable. Well, it turns out that I cannot solve this equation number 1, because it's one equation and it's two unknown. So I cannot start solving procedure with equation number 1. Now if you go to equation number 2, again I have ay and t. So I can't solve it. One equation, two unknown. But look at equation 3. I only have one unknown, and that's the tension in the cable. So let's use equation 3 and solve for t, and then I can find the reaction ax and ay, and that's the end to the problem, right? So solving equation 3, it gives you 3 times t, because this 5 is going to cancel out with this 5, so you get 3t is equal to, take this to the right hand side, so 1500, right? So that's what you get, and then your t is equal to 1500 divided by 3, which is 500 Newton. So this is the tension in the cable if your system stays at equilibrium, which is the subject of this problem. Now let's go, you can either go to equation 1 or equation 2, right, because you have t. Now let's go to equation 1. I get ax is equal to negative 4/5 times t. Now t is 500, so I get negative 4/5 times 500, and that's going to give me 100 times 4, negative 400 newtons, right? Now let's go to equation number 2. Ay is equal to 500 negative 3/5 times t. Substitute value 500 for t, then you get 500 negative 3/5 times 500. Alright, this cancel out with this. 500 minus negative 300, you get 200 Newton positive. Now look at these signs. This guy is a positive value, right? This guy is a negative. In fact, if you go back to the original picture right here, now I need to use a different color. So you see this 2 force right here. In fact, as a matter of fact, the sign of ay that we originally chose is correct, is upward. But the sign of ax, as you can see, there is a negative here. That means that it's to the left and it's not to the right. So the moral is, it doesn't matter what sign you initially choose, right? What direction you initially choose. It automatically, during the solution procedure, you get the right direction or right sign at the end. Well, let's go to step number 5. So I'm gonna finish this and check mark step number 4, and now I want to work on step number 5. Verify. How can I verify this problem? Well, the first thing I say is, I got a cable here, right? So if the force in the cable is negative, that means it's compression, because look at this sign. The tension was my assumption, so this assumption should be the same at the end of the problem. So I look at the sign of tension here. Look, it's already positive. You see that? So my solution is probably correct. I should not suspect to this solution. If I had like negative 500, then I would have said, well, something is wrong, and then I should have gone and do the second iteration and check all the equation and derivation and see something what was missing somewhere here. So but right now I got a positive, so this seems to be a correct solution. Now we are ready to finish this problem. So I check mark step number 5. So the final answer is, the tension in cable is 500 Newton, and the reaction at point A is 200 Newton in the y direction and 400 Newton in the x direction in the negative side. And this is the solution to the problem.